All right, today we're here to consider how net force can affect the acceleration of a system with a constant mass. We have a cart, string, and a hanger here over a pulley. There is a photo gate which shoots a beam of light through a pulley with spokes on it that can keep track of position time data. That's hooked up to a computer. It can build position versus time graphs, a velocity versus time graph. From that, we can take the slope of the velocity versus time graph and find the acceleration. In order to increase the net force, we're going to need to add masses to this hanger so that it's pulling harder on the system. But to add those masses from somewhere else would change the mass of the system as well. And you're only allowed to change one variable in an experiment. So the masses that we're eventually going to add to the hanger, we're going to put those on the cart for now. And so we're going to start with 4 20-gram masses on the cart and a single 20-gram mass on a 5-gram hanger, so that has a mass of 25 grams. The current mass of our system is 326.2 grams, or 0.3262 kilograms. You can look at a previous video on how we went massing the system, but the mass of this system might be different than that. Again, it's 326.2 grams. So for one of these trials, we will remove this mass. We're going to go ahead and hit data collection with the computer. And catch the cart before the mass is at the floor. Now for the data collection, we're going to pivot you over here. We're going to take a look at this computer, and the slope up here for the graph, we have to highlight the good part of that graph, which is right here. We'll go ahead and find the slope of that. And we've got a slope of 0.7525. Again, that's 0.7525 is our first acceleration for that. The kids in class today took 3 accelerations from the computer, but we are just going to do 1 for each of the trials here. And hopefully we can see this for the most part. So now, to increase the net force, we're going to take a mass off the hanger or off the cart and move it to the hanger. So we now have a 45-gram hanger. And we'll go ahead and start the computer and catch. And the slope of this graph is 1.329. Again, that's 1.329 meters per second squared. So now we're going to go ahead and move another mass from the cart to the hanger. Data collection and catch it. The slope of this graph is 1.924. Again, that's 1.924 meters per second squared. We're now going to move the third of our 4 masses from the cart to the hanger. That again, it increases the net force. And we'll measure the corresponding acceleration. In this case, the graph didn't give us a very clean line on this, so I'm going to have to select the data. Notice we're going to pick from the linear portion of the graph here. And again, we'll go up here and choose the slope button on here. The slope here is 2.496. We're going to move the 4th mass from the cart onto the hanger. I don't know if you can see that, but there's now so much mass on the hanger, and it now is exerting such a force it's pulling that black bar. We're going to go ahead and hit the space bar and release, and go ahead and find that slope. And this slope is 3.031 meters per second squared. Again, the slope of this velocity versus time graph is 3.031 meters per second squared. And you can use this data collection if you were not in class today. I hope that helps.